What's going on, everybody? You're welcome to Spencer's Academy. We have a nice, beautiful differentiation question on the board that we're going to solve. Very interesting question. Now, if you're new to this channel, here we solve calculation questions across many courses. And if that's what interests you, you can go ahead and click the subscribe button, turn on the notification bell so you don't miss my upcoming video. Now, this is a nice question we are going to be doing. If you know you have idea or you can solve this question, go ahead and do that. You can pause the video if you want. Go ahead and put your answer on the comment section once you are done. I guess we're through. Now, let's see if what we did was correct. We have y equal to f of x equal to 2 the fifth root of s to the power 3 plus sine 5x times exponential 3x. The question asks us to find the y, the s. Now, what do? I'm going to just write y instead of this f of s. They are both the same thing. So let me write y equal to 2 times the fifth root, this is fifth root, of x to the power 3 plus sine 5x times exponential 3x. Now, we have to make this one simple. You know, a root is also identified as a fractional power. That means I can write it like this. This is 2 times x. You know, when root is being identified as a fractional power, the power here on this s is the numerator, while the root is the denominator. That's how to identify roots on a power basis. So a root is a fractional power, whereby the power remains the numerator, then the root is the denominator. Now let's write plus sine 5x exponential 3x. Now, since we've made everything simple, it is now time for us to solve this question, finding the derivative. So the derivative of y is the y ds equal to 2 is a constant. Now, if I want to differentiate s to the power of 3 over 5, according to differentiation, we have to use this power to multiply the coefficient here. So the power is 3 over 5. So we're using the 3 over 5 to multiply the 2, which we just did, x. Now, this power, we remove 1. We have to remove 1 from it. So we have 3 over 5 minus 1. That's it. Plus. Now, watch here. This is sine 5x multiplying exponential 3s. And in differentiation, when two functions are multiplying, we apply what is called the product rule. And product rule says that the differential is equal to, you differentiate u, you owe v constant, plus you differentiate v, you owe u constant. Please, this prime you see here means differentiation. That means I'm differentiating u, I'm holding v constant. You see that v does not have the prime. Here, v has prime, u does not. So differentiate u, owe v constant, plus this time around, differentiate v and OU constant. So what is going to be our u here? Our u should be sine 5x, and our v is going to be this exponential 3s. So we are differentiating u, so I'm going to write sine 5x here, sine 5x, which is my u. I'm going to differentiate it. So I'm putting a prime there, showing that I'm going to be differentiating sine 5s, which is my u. Then I'm holding v constant. V is exponential 3s. So let me put it there, exponential 3x. Plus, we're following the formula of product rule. This time I differentiate v. V is exponential 3s, so I'm going to differentiate that. So exponential 3x. Let me put prime there, showing that I'm differentiating this man. Then I'm holding u constant. U is sine 5s, so I'm holding this one constant, 5x. Now let's do the differentiation. So we have the y ds here to be equal to 2 times 3 gives 6 over 5. Now, x, we have to subtract this. How do we do that? So 5 times this one is 5, right? So 3 minus 5 gives minus 2. So write minus 2 all over the denominator. That's it. Plus, now let's differentiate sine 5s. How do we differentiate a trig? We do that by saying maybe I have sine kx. I will have to differentiate the angle. When I differentiate the angle, which is ks, I have k. Then I have to differentiate sine. When I differentiate sine, I get what? Cos. You see that? Now write the angle, the original angle given to you in the question. And that's what we're going to do here now. So we focus on the angle first. When I differentiate the angle, which is 5s, I get what? 5. So I'm going to be writing the 5 here. Now when I differentiate sine, I have cosine. Now write the original angle, which is 5x. So we're done differentiating sine 5s as 5 cos 5s. Now write your constant, which is exponential 3x, plus, this time around we're differentiating exponential 3s. We do the same thing. We differentiate the power. When I differentiate 3s, what is the power? 3s when I differentiate is what? 3. Now, use this 3 to multiply the original question, which is exponential 3s. That's how to differentiate an exponential function. You differentiate the power and use the result to multiply the question, the original question given to you. Now write sine 5s, which is a constant. So yes, we are on track. Now let's simplify this given expression. Let's simplify here. Let me just remove this so I have enough space. So that means my dy ds becomes 6 over 5. Now, a negative power indicates an inverse. That's it. So that means I'm going to be writing an inverse of x to the power of 2 over 5 because of this negative power. So this means an inverse, which is 1 all over x to the power of 2 over 5. So you see that the negative power is no longer there because it has been replaced by this inverse. Plus 5 cos 5x exponential 3x plus, okay, I should need a space, plus 3 exponential 3x sine 5x. Now, we're going to have the y ds to be equal to 6 times 1 is 6 all over 5 times x to the power of 2 over 5 is 5x to the power of 2 over 5. That's it. Plus, now if we wash this expression and this expression, you notice that exponential 3s is common. So we have to factorize that out. Exponential 3s is common. So bring it out. Now, what will remain here? I have 5 cos 5s. So 5 cos 5x plus what will remain here is 3 sine 5x. So write it down. 3 sine 5x. That is it. Now we need to write this in a more simpler form. Remember, it was in a root sign. So instead of writing a fractional power, we're going to replace that with a root because a fractional power represents roots, right? So the y/ds becomes 6 over 5. Now remember, we said the root is the denominator. So it's going to be a fifth root because the denominator is 5. So it's going to be a fifth root. X. Then the numerator is the power, s to the power 2. That is it. Plus exponential 3x into 5 cos 5x plus 3 sine 5x. There you have it. If you can be able to solve like this, there I assure you that you're going to get your answer right. You will never be wrong. Well, if you enjoyed this video, go ahead and give this video a thumbs up. Subscribe if you haven't. Turn on the notification bell so you don't miss my future videos. And until next time, take care.